Okie dokie. In this video, I will be working out 8 questions that will serve as somewhat of a practice exam for 1026. The real test will be whether I can record this with 11% battery. So let's give it a run. 8 problems starting now. Number 1, true or false, the integral of e to the x dt is equal to e to the x plus c. It's so close to being true, but what do you notice about the variables? We have e to the x, and we're integrating it with respect to t. The integral of e to the x with respect to t, well, e to the x at that point would be a constant. It'd be treated as just a constant because the real variable is t, and so the integral of a constant would just be that constant times t plus c, and so they would never write this, so this is false. What would have made this true in an easier way is just if it had been the integral with respect to x. So e to the x dx would be e to the x plus c. Number 2, which of the following statements is true? Now they say the integral of f of t dt, one of the antiderivatives of f of x. I don't even know what they're trying to say there, so I'm going to assume that's false. I'm just going to cross it out here if I can. What's going on? There we go. B, if capital F of x, all right, we're at 10 now, let's keep it going. If capital F of x is the antiderivative, or is an antiderivative for lowercase f of x, then it is true that f of x equals the derivative of lowercase f of x. Okay, so notice they're saying fx is the antiderivative of lowercase f. And so, in other words, the integral of f is equal to capital F. So it is true that f is equal to the derivative of f? No, just the opposite. Big F is equal to the integral of f, not f prime. That doesn't make any sense. So C, integral from a to b of f of x dx represents the area of a specific region under f of x and above the x-axis between x equals a and x equals b. I'll be honest, that sounds pretty solid. I'm going to give that a big check mark, and I'm going to verify that D is false. D, the antiderivative of sine of x with respect to x is sine of x dt? No. It would be if it were dx. With respect to x means dx, but with respect to x, then having a dt makes it false. So C is our answer. Note that that's the second option listed here. All right, number 3. Select the correct antiderivative term for the following function. Okay, so they found the antiderivative of this. They got 1 over 2 e to the 2x, good, plus 3 to the x, which would have an antiderivative of 3 to the x, divided by, excuse me, e to the x divided by the natural log of 3. Now, where's that coming from? Well, the derivative of the derivative of 3 to the x is 3 to the x ln of 3. And so the question would be like, what must this have been so that it's, how am I wording this? I guess, yeah, so how would the derivative of something be just 3 to the x? And so we make it 3 to the x divided by ln of 3, because when we take the derivative, we get 3 to the x ln of 3 over ln of 3, and those cancel, and it leaves us with just the 3 to the x. That's why the anti of 3 to the x is just 3 to the x divided by ln of 3. Hope that makes enough sense. Let's go to the next term. Negative cosine of x would be, I think, just negative sine of x, because the derivative of sine of x is cosine of x. So we know the integral of cosine is sine, so then the integral of negative cosine is negative sine. Yeah, that's valid. All right, next one, x to the negative 4 is x to the negative 3 divided by negative 3. Yep. Minus 6 would be minus 6. Oh, wait. What the heck? Why they got x's? They have x's and t's in the mix. Okay, so I was right by using x's previously. So negative 6x for the negative 6. That's straightforward. but then they have plus 2t. I don't know if the 2t is an accident. Maybe it should have been 2x. If it is meant to be 2t, then the answer would be 2tx. But I'm assuming they meant to do x, so I would call it x squared. So the antiderivative of 2x is x squared. All right, I'm going to leave it at that. Let's go to number 4. Evaluate the integral. So antiderivative, and then we'll evaluate from 0 to 3. So add a power, divide by that new number. Constant goes to the constant times x. Evaluate this from 0 to 3. Plug in the 3, plug in the 0. If we plug in the 3, we get 3 cubed over 3 plus 2 times 3, so 6. And then plug in the 0, you get 0 plus 0. So we have the 3 evaluation minus the 0 evaluation. We get 3 cubed over 3 is just 3 squared, or 9, plus 6. That's 15. That's our whole number answer. Halfway through, number 5. Rate of growth is given by r prime. T is time in months. This units for this rate are given in inches per month. To calculate the accumulated growth for the plant from month 1 to month 4, we could find this by calculating the integral from 1 to 4 of r prime of t dt. True or false? I think that is true. So month 1 to month 4, 1 to 4, t is time in months, so that checks out. When you integrate a rate of change, that is, I guess we'll just call it like growth, or growth over time. So growth per month, basically, over a change in months. What you get is just the change in growth. The change in whatever that top unit is. So for example, if it was like, if you were integrating miles per hour in respect to hour, so d hour, you would get change in miles. So the change in distance, you'd get the distance between A and B. Okay, so that's why it's, calculate the accumulated growth or change in growth from 1 to 4. So this is a true statement. Okay. Number 6, suppose you have a function. You want to integrate it from 3 to 7 with a step size, a delta t of 1, meaning you'd have rectangles between 3, 4, 5, 6, and 7. Step size is 1, so 1 rectangle, 2 rectangles, 3 and 4 rectangles. Which of the following table rows has the correct information for left, right, midpoint sums to solve this problem? So they say which of the following rows. Okay, so the entire row has to be true. Okay, interesting. So let's talk about a couple things. For a left sum, we would use the f values that come from these x values. In other words, we use the leftmost values and we leave off the 7 for a left sum. So in other words, a left would use 3, 4, 5, 6. For a right sum, we'd leave off the leftmost value and we'd use 4, 5, 6, and 7. And again, those are the x values that lead to the f values that we would use. So note how they're saying we'd use the f values. The f values give us the height of the rectangles, right? So I'm just shorthanding it by saying we're just using those x values because we're getting the f values from those x values. Now, easy enough for those. Midpoints. Which x values are we using for the midpoints? Well, they got to come from halfway between these x values that we have here. So for a midpoint, we'd use 3.5, 4.5, 5.5, and 6.5. So I will not write them again. I'll just say these are for the midpoints. And again, we'd use the f values from these x values. Got it? All right. So let's go through each row here. Let's see. Left sum uses f of 3. Yep. Left sum uses f of 5.5. No, a left sum uses 5 and it uses 6. It does not use 5.5. So that's out. So I'm going to say this row is out if one of the things is already out. Right sum uses f of 3. No, that is correct. Uses f of 5.5. It says yes, but that is wrong. The right sum only uses 4, 5, 6, and 7. It does not use 5.5, so that's out, which means this whole row is out. Midpoint sum uses 3? No. Midpoint sum uses 3.5. So that can't be right either. So just like that, all these rows are not correct. So none of these rows are correct. All right. I hope that makes sense. All right, let's keep it going. Number 7, use the stated method to approximate the area under the curve, x squared, from 0 to 4, 2 subintervals. So we're going from 0 to 4, but we're only using 2 subintervals, so 2 rectangles. And so what must be in the middle? A big old 2. If you need to calculate it, you do b minus a over n. So you get 4 over 2, which is 2. 2 represents the width of each rectangle. Now, we not only need these x values, we of course need the y values associated with these x values. Plug in the x to get the f, or get the y. And so plug in 0 to 0 squared, or to x squared, and you get 0. Plug in 2 to x squared, and you get 4. Plug in 4 to x squared, you get 16. How are we doing on charge here? We got 6%. We're crushing it. All right. So once you get your y values, again, these are potential heights of rectangles depending on the sums you are using. All right, for a left sum, the width is 2, and you add up the 2 heights we are using, and that would be 0 and 4. 0 plus 4. 2 times 0 plus 4 is 8. That's for the left sum, that is 8. Oh, I realize they're not asking for a right sum now. So instead of a right sum, we need to use a midpoint sum, which would be using x values of 1 and 3, because we're going halfway between the other x values, right? So we'll get those y values for these. So 1 squared is 1. 3 squared is 9. So those are the heights that come from the middle values of where these rectangles are. The rectangles going from 0 to 2 and from 2 to 4. And so halfway between those rectangles is the x values of 1 and 3. And so we plug those in to get the heights of the rectangles from those x values. So again, the width is still 2 for each rectangle, but the height is 1 and 9 for each of those rectangles. So that would give us 2 times 10, which is 20 for the midpoint sum. Okay? Okay. Number 8, note. Well, what's up with all this yelling here? Why are you yelling? All right. You got to know how to do certain integrals, not this exact one, but maybe a similar integral. Number 8, they give you s prime, and they say solve the initial value problem, s prime, and s of 0 equals 2. Okay, so it's the idea where you want to find the antiderivative, add c, and then once you have that with the plus c, you'll plug in 0 for x and 2 for s. And now, how'd they mess this up this bad? The s's and the x's and t's are crazy. I'm going to use x's instead of t, okay? Because most of these have x's. So s prime of x. All right, so antiderivative starting with 1 over 2x plus 1. You'd likely want to use u sub for this first one right here. So 1 over, let me break it down like this for you. We're integrating or finding the antiderivative of 1 over 2x plus 1. So we're going to break it down piece by piece. Our u is 2x plus 1. Our du is 2 dx. Our du over 2 is equal to dx. We solve for dx. Replace or rewrite the integral. We have 1 over u. In place of dx, we have du over 2. We pull out the 2. In other words, pull out the 1/2. We are left with 1 over u du, which we can now more easily integrate now that it's a simpler integral than this, just slightly. So we find the antiderivative of 1 over u. We get ln of u, 5%. Here we go. Home stretch. 1/2 ln of u, and again, we just get it back in terms of x. So 1/2 ln of absolute value of 2x plus 1. Okay, that should be the first term. So then moving on, sine of x has an integral or antiderivative of negative cosine of x, because cosine of x has a derivative of negative sine of x, but then that extra negative negates that negative and makes it a positive sign. So negative cosine is the antiderivative of positive sine. So then minus 4x would be minus 4x squared over 2. 4 over 2 reduces to 2. And this is our s of x. This is just our general antiderivative. Make sure to add c, because now our final step is to plug in 0 for x, 2 for s, and solve for c. So we have 1/2 ln of 2x, so 0. So it's ln of 2 times 0 plus 1. Again, I plugged in 0 there, so 2 times 0 plus 1, that's just 1. Plus, and once we plug something in, you can kind of drop the absolute value. And then minus, I'll just call it minus cosine of 0, minus 2 times 0, so just 0, plus c. So again, we plugged in 2 for s, 0 for x. Ln of 1 is 0. Cosine of 0 is 1. So really all we're left with is 2 equals 0 minus 1 plus c. C is equal to 3. Now the only thing left to do is rewrite this function with 3 plugged in place of c. You will keep the absolute value. I'll go ahead and call this just minus cosine. But that right there would be your final result for s of x, for your antiderivative. Okay, so that's what it means to solve the initial value problem. We find s of x, we find the original function, and we find the c, because that makes up what the actual function is. All right, we did it with 4% to spare. If you have any questions, please let me know. That was problems 1 through 8. If you have any questions, let me know.